Definition of expectation. An average of a probability distribution of a random variable x is called the expectation or the expected value or mathematical expectation of x and is denoted by E of x, discrete random variable. Let x be a discrete random variable taking values x1, x2, x3, etc. with probabilities p of x1, p of x2, p of x3, etc. Then the expected value of x is defined as E of x equals summation I equals 1 to infinity xi into p of xi. Continuous random variable. Let x be a continuous random variable with PDFF defined in -infinity to infinity. Then the expected value of x is defined as E of x equals integral -infinity to infinity x f of x dx. Note 1. E of x is called the mean of the distribution or mean of x and is denoted by x bar or mu. 2. E of x square equals summation xi square into p of xi, if x is discrete. Equals -infinity to infinity x square f of x dx, if x is continuous. Properties. 1. If c is constant, then E of c equals c. 2. If a, b are constants, then E of ax plus b equals a into E of x plus b. Definition of variance. Let x be a random variable with mean E of x, then the variance of x is defined as E of x minus E of x whole square. It is denoted by variance of x or sigma x square. That is variance of x equals E of x minus E of x whole square. For discrete random variable, if x is a discrete random variable taking values x1, x2, x3, etc. with probabilities p of x1, p of x2, p of x3, etc. and E of x equals mu, then variance of x equals summation over ixi minus mu whole square into p of xi. For continuous random variable, if x is a continuous random variable with PDFF of x, x belongs to -infinity to infinity, then variance of x equals integral -infinity to infinity xi minus mu whole square into p of xi dx. Properties. If a, b are constants, then 1. Variance of a equals 0, 2. Variance of ax equals a square into variance of x, and 3. Variance of ax plus or minus b equals a square variance of x. Note, variance of x equals E of x square minus E of x whole square. Problem 1. If x has the probability distribution. X takes value -1 0 1 2. P of x takes value 0.3 0.1 0.4 0.2. Find E of x square, var of x, E of 2x plus 1 and variance of 2x plus 1. Solution. 1. E of x equals summation xi p of xi equals -1 into plus 0 into 0.1 plus 1 into 0.4 plus 2 into 0.2 is equal to 0.5. 2. E of x square equals summation xi square p of xi equals -1 whole square 0.3 plus 0 into 0.1 plus 1 square into 0.4 plus 2 square into 0.2 is equal to 1.5. 3. Variance of x equals E of x square minus E of x whole square equals 1.5 minus 0.5 square equals 1.25. 4. E of 2x plus 1 is equal to 2 into E of x plus 1 is equal to 2 into 0.5 plus 1 is equal to 2. 5. Variance of 2x plus 1 is equal to 4. Variance of x equals 4 into 1.25 is equal to 5. Problem 2. If x has the probability distribution. X takes value 0 1 2 3 4. P of x takes value 1 by 25, 3 by 25, 5 by 25, 7 by 25, 9 by 25. Find mean, variance, e of 3x minus 4 and variance of 3x minus 4. Solution 1. Mean equals e of x equals summation xi into p of xi equals 0 into 1 by 25 plus 1 into 3 by 25 plus 2 into 2 by 25 plus 3 into 7 by 25 plus 4 in 9 by 25 equals 70 by 25 or 14 by 5. 2. E of x square equals summation xi square p of xi equals 0 into 1 by 25 plus 1 square into 3 by 25 plus 2 square into 2 by 25 plus 3 square into 7 by 25 plus 4 square into 9 by 25 equals 230 by 45 or 46 by 5. Variance of x equals e of x square minus e of x whole square equals 46 by 5 minus 14 by 5 whole square equals 34 by 25. 3. E of 3x minus 4 is equal to 3 into e of x minus 4 is equal to 3 into 14 by 5 minus 4 is equal to 22 by 5. 4. Variance of 3x minus 4 is equal to 9 into variance of x equals 4 into 34 by 25 is equal to 306 by 25. Problem 3. In a gambling game of tossing 4 coins once, a man gets rupees 10 if he gets all heads or all tails and loses rupees 5 if he gets 1 or 2 or 3 heads. What is his expected gain? Solution. Let x denote the amount gained. The possible values of x are 10, minus 5. P of x equals 10 equals P of getting 4 heads or 4 tails equals 1 by 16 plus 1 by 16 is equal to 1 by 8. P of x equals minus 5 equals P of 1 head and 3 tail or 2 head and 2 tail or 3 head and 1 t-tail equals 4c into 1 by 16 plus 4c2 into 1 by 16 plus 4c3 into 1 by 16 is equal to 7 by 8. The probability distribution of x is x takes value minus 5, 10. P of x takes value 1 by 8, 7 by 8. Therefore E of x equals summation xi into P of xi equals minus 5 into 1 by 8 plus 10 into 7 by 8 equals minus 25 by 8. Problem 4. A coin is tossed until a head appears. What is the expected value of the number of tosses? Solution. Let x denote the number of tosses required to get the first success, head. Therefore the head can appear in the first toss or second toss or third toss and so on. That is, the events are h, th, tth, ttth, etc. Therefore the probabilities are 1 by 2, 1 by 2 square, 1 by 2 cube, etc. E of x equals summation xi into P of xi equals 1 by 2 plus 2 into 1 by 2 whole square plus 3 into 1 by 2 whole cube plus etc. equals 1 by 2 into 1 plus 2 into 1 by 2 plus 3 into 1 by 2 whole square plus etc. equals 1 by 2 into 1 minus 1 by 2 whole power minus 2 is equal to 2. Problem 5. A man draws 3 balls from an urn containing 5 white and 7 black balls. He gets rupees 10 for each white ball and rupees 5 for each black ball. Find his expectation. Solution. Let x denote the amount gained. 3 balls drawn may be I, 3 black, 2 black and 1 white, 3, 1 black and 2 white and 4, 3 white. Therefore the values of x are 15, 20, 25, 30. P of x equals 15 equals P of 3 black balls equals 7 C3 by 12 C3 is equal to 7 by 44. P of x equals 20 equals P of 2 black and 1 white equals 7 C2 into 5 C1 by 12 C3 is equal to 21 by 44. P of x equals 25 equals P of 1 black and 2 white equals 7 C1 into 5 C2 by 12 C3 is equal to 14 by 44. P of x equals 30 equals P of 3 white balls equals 5 C3 by 12 C3 is equal to 2 by 44. The probability distribution of x is: x takes value 15, 20, 25, 30. P of x takes value 7 by 44, 21 by 44, 14 by 44, 2 by 44. Therefore E of x equals summation xi into P of xi equals 15 into 7 by 44 plus 20 into 21 by 44 plus 25 into 14 by 44 plus 30 into 2 by 44 is equal to 935 by 44. Problem 6. Find the expectation of the number of failures preceding the first success in an infinite series of independent trials with constant probability p of success in each trial. Solution: let x denote the number of failures preceding first success. Then the events are s, fs, ffs, fffs, etc. Hence x takes the values 0, 1, 2, 3, etc. and the corresponding probabilities are p, qp, q square p, q cube p, etc. Therefore E of x equals 0 into p plus 1 into qp plus 2 into q square p plus 3 into q cube p plus etc. equals qp into 1 minus q whole power minus 2 equals qp into 1 by p square equals q by p. Problem 6. Find the expectation of the number of failures preceding the first success in an infinite series of independent trials with constant probability p of success in each trial. Solution: let x denote the number of failures preceding first success. Then the events are s, fs, ffs, fffs, etc. Hence x takes the values 0, 1, 2, 3, etc. and the corresponding probabilities are p, qp, q square p, q cube p, etc. Therefore E of x equals 0 into p plus 1 into qp plus 2 into q square p plus 3 into q cube p plus etc. equals qp into 1 minus q whole power minus 2 equals qp into 1 by p square equals q by p. Problem 7. Find the mean and variance of the following density function f of x equals x, 0, x less than 1. Equals 2 minus x, 1 less than or equal to x less than 2. 0, otherwise. Solution: E of x equals integral minus infinity to infinity x f of x dx equals integral 0 to 1 x into x dx plus integral 1 to 2 x into 2 minus x dx equals x cubed by 3 limit 0 to 1 plus 2x square by 2 minus x cubed by 3 limit 1 to 2 equals 1 by 3 plus 4 minus 8 by 3 minus 1 by 3 is equal to 1. E of x square equals integral minus infinity to infinity x square f of x dx equals integral 0 to 1 x square into x dx plus integral 1 to 2 x square into 2 minus x dx equals x power 4 by 4 limits 0 to 1 plus 2x cubed by 3 minus x power 4 by 4 limits 1 to 2. e of x square equals 1 by 4 plus 2 power 4 by 3 minus 2 power 4 by 4 minus 2 by 3 minus 1 by 4 equals 1 by 4 plus 2 power 4 into 1 by 3 minus 1 by 4 minus 8 minus 3 divided by 12 is equal to 14 by 12 or equals 7 by 6. Variance of x equals e of x square minus e of x whole square equals 7 by 6 minus 1 is equal to 1 by 6. Problem 8. The density function of a continuous random variable x is given by f of x equals x by 2, if 0 x less than 2 equals 0, otherwise. Find I, the expectation of x, 2, variance of x, and 3, e of 3x square minus 2x. Solution 1. E of x equals integral minus infinity to infinity x into f of x dx equals integral 0 to 2x into x by 2 dx equals 1 by 2 into x cubed 3 by 3 limit 0 to 2 is equal to 4 by 3. 2. Variance of x equals e of x square minus e of x whole square. Now e of x square equals integral minus infinity to infinity x square f of x dx equals integral 0 to 2x square into x by 2 dx equals 1 by 2 into x cubed 4 by 4 limit 0 to 2 is equal to 2. Therefore variance of x equals 2 minus 4 by 3 whole square equals 2 by 9. 3. E of 3x square minus 2x equals 3 e of x square minus 2 e of x equals 6 minus 8 by 3 is equal to 10 by 3. Problem 9. Find the expectation and variance of the random variable x whose PDF is given by f of x equals 2e power minus 2x, if x greater than 0. 0, otherwise. Solution 1. E of x equals integral minus infinity to infinity x into f of x dx equals integral 0 to infinity x into 2e power minus 2x dx equals 2 into x e power minus 2x by minus 2 minus e power 2x by 2 square limits 0 to infinity equals 1 by 2. 2. Variance of x equals e of x square minus e of x whole square. Now e of x square equals integral minus infinity to infinity x square f of x dx equals integral 0 to infinity x square into 2e power minus 2x dx. E of x square equals 2 into x square into e power minus 2x by minus 2 minus 2x into e power minus 2x by 2 square plus 2 into e power minus 2x by minus 2 whole cube limit 0 to infinity equals 1 by 2. Therefore variance of x equals 1 by 2 minus 1 by 4 is equal to 1 by 4. Problem 10. A continuous random variable has PDF f of x equals a plus bx, 0 less than or equal to x less than or equal to 1 equals 0, otherwise. If the mean of the distribution is 1 by 2, then find a, b. Also evaluate variance of x. Solution. We know that integral minus infinity to infinity f of x dx equals 1. Implies integral 0 to 1 a plus bx dx equals 1 implies that ax plus bx square by 2 limit 0 to 1 is equal to 1. Implies 2a plus b equals 2 equation number 1. Given e of x equals 1 by 2. Implies integral minus infinity to infinity x f of x dx equals 1 by 2 implies integral 0 to 1 x into a plus bx dx equals 1 by 2 implies that ax square by 2 plus bx cubed by 3 limit 0 to 1 is equal to 1 by 2. Implies 3a plus 2b equals 3 equation number 2. Solving equations 1 and 2, we get a equals 1, b equals 0. Now e of x square equals integral 0 to 1 x square f of x dx equals integral 0 to 1 x square into a plus b x dx equals integral 0 to 1 x square dx equals 1 by 3. Therefore variance of x equals e of x square minus e of x whole square 1 by 3 minus 1 by 4 is equal to 1 by 12. Problem 11. Let x be a random variable with e of x equals 10 and v of x equals 25. Find the positive values of a and b such that y equals ax minus b has expectation 0 and variance 1. Solution: given e of x equals 10, v of x equals 25, e of y equals 0, v of y equals 1. Now e of y equals e of ax minus b equals a into e of x minus b implies 0 is equal to 10 a minus b equation number 3. And variance of y equals variance of ax plus b equals a square into variance of x implies 1 equals a square into 25 implies that a square equals 1 by 25 equation number 4. Solving equations 3 and 4. We get a equals 1 by 5, b equals 2. Problem 12. If x has the distribution function f of x equals 0, for 0 less than or equal to x less than 1. Equals 1 by 3, for 1 less than or equal to 4. Equals 1 by 2, for 4 less than or equal to 6. Equals 5 by 6, for 6 less than or equal to 10. Equals 1, for x greater than or equal to 10. Find 1 the probability function of x, 2, p of 2x less than 6, 3, mean of x and 4, variance of x. Solution: 1 we know that p of x equals xi minus f of xi minus 1. P of x equals 1 equals f of 1 minus f of 0 is equal to 1 by 3 minus 0 is equal to 1 by 3. P of x equals 4 equals f of 4 minus f of 1 is equal to 1 by 2 minus 1 by 3 is equal to 1 by 6. P of x equals 6 equals f of 6 minus f of 4 is equal to 5 by 6 minus 1 by 2 is equal to 1 by 3. P of x equals 10 equals f of 10 minus f of 6 is equal to 1 minus 5 by 6 is equal to 1 by 6. Therefore the probability distribution x is x takes values 1 for 6 10. P of x takes values 1 by 3 1 by 6 1 by 3 1 by 6. 2. P of 2x less than 6 equals P of x equals 4 is equal to 1 by 3. 3. Mean of x equals e of x equals summation x into P of x, e of x equals 1 into 1 by 3 plus 4 into 1 by 6 plus 6 into 1 by 3 plus 10 into 1 by 6 is equal to 14 by 3. 4. Variance of x equals e of x square minus e of x whole square. Now e of x square equals summation x square into P of x equals 1 into 1 by 3 plus 16 into 1 by 6 plus 36 into 1 by 3 plus 100 into 1 by 6 is equal to 95 by 3. Therefore variance of x equals 95 by 3 minus 14 by 3 whole square equals 89 by 9. Problem 13. The cumulative distribution function of a random variable x is f of x equals 1 minus of 1 plus x into e power minus x, x greater than 0. Find the probability density function of x, mean and variance of x. Solution: f of x equals d by dx f of x equals d by dx into 1 minus of 1 plus x into e power minus x. Implies f of x equals d by dx into 1 minus e power minus x into e power minus x, x greater than 0. Mean equals E of x equals integral 0 to infinity x into f of x dx equals integral 0 to infinity x square into e power minus x dx. Implies E of x equals x square into e power minus x by minus 1 minus 2x into e power minus x by 1 plus 2 into e power minus x by minus 1 limit 0 to infinity equals 2. E of x square equals integral 0 to infinity x square into f of x dx equals integral 0 to infinity x cube into e power minus x dx. Implies E of x square equals x cube into e power minus x by minus 1 minus 3x square into e power minus x by 1 plus 6x into e power minus x by minus 1 minus 6 into e power minus x by minus 1 limit 0 to infinity equals 6. Therefore variance of x equals E of x square minus E of x whole square equals 6 minus 4 is equal to 2. Moments. The expected value of an integral power of a random variable is called its moment. Moments about the origin or raw moments. The RTH moment of a random variable x about the origin defined as E of x power r and is denoted by mu r dash. Therefore mu r dash equals E of x power r. The first form moment about the origin are mu1 dash equals E of x equals mean, mu2 dash equals E of x power 2, mu3 dash equals E of x power 3 and mu4 dash equals E of x power 4. Moment about the mean or central moments. The RTH moment of a random variable x about the mean, mu, is defined as E of x minus mu whole power r and is denoted by mu r, therefore mu r equals E of x minus mu whole power r. The first four moments about the mean are 1 mu 1 equals E of x minus mu equals mu minus mu equals 0. Therefore for any distribution discrete or continuous, the first moment about its mean is 0. 2. Mu2 equals E of x minus mu whole power 2 equals variance of x. 3. Mu3 equals E of x minus mu whole power 3. 4. Mu4 equals E of x minus a whole power 4. The moments about any point A. The RTH moment of a random variable x about a pointer is defined as E of x minus a whole power r and is denoted by mu r dash. Therefore mu r dash equals E of x minus a whole power r. The first four moments about the pointer are mu1 dash equals E of x minus a equals E of x minus a equals mu minus a. Therefore mu equals mu1 dash plus a. Mu2 dash equals E of x minus a whole square, mu3 dash equals E of x minus a whole cube and mu4 dash equals E of x minus a whole power 4. Relation between moments about the mean and moments about any point A, mu1 is equal to 0. Mu2 equals mu2 dash, mu1 dash square. Mu3 equals mu3 dash minus 3 mu2 dash mu1 dash plus 2 mu1 dash cube. Mu4 equals mu4 dash minus 4 mu3 dash mu1 dash plus 6 mu2 dash mu1 dash square minus 3 mu1 dash power 4. Problem 1. The first four moments of a distribution about x equals 4 are 1, 4, 10, 45. Show that the mean is 5, variance is 3, mu3 is equal to 0, mu4 is equal to 26. Solution. Let mu1 dash, mu2 dash, mu3 dash, mu4 dash be the first four moments about x equals 4. Given mu1 dash equals 1, mu2 dash equals 4, mu3 dash equals 10, mu4 dash equals 45 about x equals 4. Mu1 dash equals E of x minus 4 implies that 1 equals E of x minus 4 implies E of x equals 5. Variance mu2 equals mu2 dash minus mu1 dash square equals 4 minus 1 is equal to 3. Mu3 equals mu3 dash minus 3 mu2 dash mu1 dash plus 2 mu1 dash cube equals 10 minus 3 into 4 into 1 plus 2 into 1 is equal to 0. Mu4 equals mu4 dash minus 4 mu3 dash mu1 dash plus 6 mu2 dash mu1 dash square minus 3 mu1 dash power 4 is equal to 45 minus 4 into 10 into 1 plus 6 into 4 into 1 minus 3 into 1 is equal to 26. Problem 2. The first three moments about the origin are 5, 26, 78. Show that the first three moments about the value x equals 3 are 2, 5, minus 48. Solution: given e of x equals 5, e of x square equals 26, e of x cube equals 78. Let mu1 dash, mu2 dash, mu3 dash be the first three moments about x equals 3. Mu1 dash equals e of x minus 3 equals e of x minus 3 5 minus 3 is equal to 2. Mu2 dash equals e of x minus 3 whole square equals e of x square minus 6 into e of x plus 9 is equal to 26 minus of 6 into 5 plus 9 is equal to 5. Mu3 dash equals e of x minus 3 whole cube equals e of x cube minus 9 into e of x square plus 27 into e of x minus 27 is equal to 78 minus 9 into 26 plus 27 into 5 minus 27 equals minus 48. Problem 3. Find the first three moments of x if x has the following distribution. X takes value minus 2, 1, 3. P of x takes value 1 by 2, 1 by 4, 1 by 4. Solution: let mu1 dash, mu2 dash, mu3 dash be the first three moments about the origin. Mu1 dash equals e of x equals summation x into p of x equals minus 2 into 1 by 2 plus 1 into 1 by 4 plus 3 into 1 by 4 is equal to 0. Mu2 dash equals e of x square equals summation x square into p of x equals 4 into 1 by 2 plus 1 into 1 by 4 plus 9 into 1 by 4 is equal to 9 by 2. Mu3 dash equals e of x cube equals summation x cube into p of x equals minus 8 into 1 by 2 plus 1 into 1 by 4 plus 27 into 1 by 4 is equal to 3. Problem 4. A continuous random variable x has the PDF f of x equals k into x square into e power minus x, x greater than or equal to 0. Find the RTH moment of x about the origin. Hence find the mean and variance. Solution: we know that integral minus infinity to infinity f of x dx equals 1 implies integral 0 to infinity into x square into e power minus x equals 1. Implies k into x square e power minus x minus 2x e power minus x plus 2 e power minus x limits 0 to infinity equals 1. Implies k equals 1 by 2. Mu r dash equals RTH moment about the origin. Equals e of x power r equals integral minus infinity to infinity x power r f of x dx equals integral 0 to infinity x power r 1 by 2x square into e power minus x dx. Equals 1 by 2 integral 0 to infinity x power r plus 2 e power minus x dx equals 1 by 2 integral 0 to infinity x power r plus 3 minus 1 e power minus x dx. Equals 1 by 2 into gamma of r plus 3 is equal to 1 by 2 into r plus 2 factorial since gamma of n equals integral 0 to infinity e power minus x power n minus 1 dx, gamma of n equals n minus 1 factorial. Mean equals mu1 dash equals 1 by 2 into 3 factorial equals 3. Mu2 dash equals 1 by 2 into 4 factorial equals 12. Hence variance equals mu2 dash minus mu1 dash square equals 12 minus 9 is equal to 3. Problem 5. A continuous random variable x has the PDF f of x equals k into 1 minus x for 0 x less than 1. Find the RTH moment about the origin. Hence find the mean and variance. Solution. We know that integral minus infinity to infinity f of x dx equals 1 implies integral 0 to 1 k into 1 minus x dx equals 1. Implies k into x minus x squared 2 by 2 limits 0 to infinity equals 1 implies k equals 2. Mu r dash equals RTH moment about the origin. Equals e of x power r equals integral minus infinity to infinity x power r f of x dx equals integral 0 to 1 x power r into 2 into 1 minus x dx. Equals 2 into x power r plus 1 by r plus 1 minus x square r plus 2 by r plus 2 is equal to 2 divided by r plus 1 into r plus 2. Mean equals mu1 dash equals 2 divided by 2 into 3 is equal to 1 by 3. Mu2 dash equals 2 divided by 3 into 4 is equal to 1 by 6. Variance equals mu2 dash minus mu1 dash square equals 1 by 6 minus 1 by 9 is equal to 1 by 18. Problem 6. If f of x equals c e power minus x, a greater than 0 is a PDF, then find c and the first 3 moments about mean. Solution. We know that integral minus infinity to infinity f of x dx equals 1 implies integral 0 to infinity c e power minus x dx equals 1. Implies c into e power minus x by minus a limits 0 to infinity equals 1 implies c equals a. Mu1 dash equals integral 0 to infinity a x e power minus x dx equals a into x e power minus ax by minus a minus 1 into e power minus ax by a square limits 0 to infinity equals 1 by a. Mu2 dash equals integral 0 to infinity ax square 2 e power minus x dx equals a into x square e power minus ax by minura minus 2x e power minus ax by a square plus 2 e power minus ax by a cube limits 0 to infinity equals 2 by a square. Similarly mu3 dash equals 6 by a cube. Therefore mu1 is equal to 0. Mu2 equals mu2 dash minus mu1 dash square equals 2 by a square minus 1 by a square equals 1 by a square. Mu3 equals mu3 dash minus 3 mu2 dash mu1 dash plus 2 mu1 dash cube. Equals 6 by a cube minus 3 into 2 by a cube plus 2 by a cube equals 2 by a cube.